Okay, welcome back to Tom's Garage. I am going to now show you how to set up a degree wheel on a Predator 212 engine. This process will work on any Hisun 196cc engine, Predator 212, Predator 224. This is actually a Predator Ghost here. Any Honda GX200, basically any 196 clone engine, horizontal crankshaft, single cylinder, go-kart, and mini bike engines. To get started, I'll go ahead and show you what we're working with. Here I've got the degree wheel. This is a Motion Pro degree wheel. It's made of aluminum. I got it from Amazon. The link will be in the description. It is 20 bucks. I prefer this because it's easy to read. You can print your own online and tape it or glue it to a metal backing or cardboard, but I don't even own a printer, so I went and I ordered this from Amazon. I also drilled a 5/16 hole in the middle so that I could run a clutch bolt through it to attach it to my crankshaft. Next up, I've got what's called a piston stop tool. This piston stop tool is going to be what I need to zero my degree wheel out. You set the engine at top dead center to get it really close, but to get it exact, you have to have a piston stop. And I'm going to show you, that's kind of going to be the bulk of the video on how to get your degree wheel set up properly. So to get started, I'm going to set this engine at top dead center. I've already got a separate video that details that a little more slowly, so I'm going to kind of do this quickly here, but basically I'm starting off with the spark plug removed, no blower housing or pull start, and no valve cover. I'm going to rotate the engine clockwise and watch for the intake valve to open and close. So I don't know where I am in the stroke right now, so as I start to rotate, okay, I'm on the exhaust stroke. The exhaust valve is starting to open. The exhaust valve is by the exhaust itself. It's going to open and it's going to close. Now the intake valve, by the intake or the carb, it's going to open and it's going to close. Now I'm on the compression stroke and I need to get to top dead center. To do so, I'm going to place a screwdriver down in the spark plug hole, and as I rotate this slowly, that is literally riding the piston to the top of its stroke. I am at top dead center. All this extra movement here, all this dwell or dead zone at top dead center, that is exactly why we have to use a piston stop to zero the degree wheel. If we don't zero this degree wheel, all of this extra 10 to 12 degrees is going to make our readings inaccurate. So to get started, I'm going to set up the degree wheel. The degree wheel itself, you want to set up a pointer. In this case, I run a 5/16 -24 UNF fine thread bolt into this extra side cover hole. Yours may vary depending on the engine, what bolt size you need, but I'm using a piece of soldering wire. You can use coat hanger, and basically this is going to serve as a pointer. It does not matter where on the engine you have it clocked. Once you set your wheel to zero, your pointer might be at 12 o'clock, or it could be like mine, which is almost 3 o'clock. It doesn't matter where you set your pointer, but it's going to be what points to your zero on your wheel when it's zeroed and the degrees when you're reading it. I'm going to insert my clutch bolt into the degree wheel, and I like to run a washer on the back side of it, and then I'm going to carefully thread this into the crankshaft. And at top dead center on the engine, I'm going to go ahead and set my wheel on 0 degrees, and I'm just going to kind of snug it with my hand. I'm not really going to tighten it too much. Actually, I might just snug it a little bit with a wrench. Just a little. Okay, I still want to be able to move this around because we're not going to be truly zeroed yet. Now I need to use a piston stop tool. First, I'm going to actually rotate the engine backwards by about 20 degrees. I'm doing that so that when I install this piston stop, when I run this piston stop down, I want it to actually touch the piston and stop the piston and the engine motion itself. So I'm going to run this down until it hits the piston. Okay, I'm hitting the piston. If I were to keep screwing this in, it's literally going to move my degree wheel because it's going to force the piston down. Now, the whole point of having your piston stop, right now, my degree wheel is reading right at 20 degrees. You don't care about the number. 20 itself doesn't matter. It could read 30, it could read 10. What matters is when I rotate this engine 360 degrees back in the other direction, my degree wheel needs to hit on the same number. So I'm looking for it to hit on 20 in both directions. If it doesn't hit on 20, I have to make fine adjustments to my degree wheel, rotating it on the crankshaft until that number matches when you rotate the engine in both directions. So I'm going to take and I'm going to rotate the engine back the other direction until it hits the piston stop again. Okay, I'm on the piston stop. What does my degree wheel read? It reads 15. So I need to basically split the difference here and adjust it by about 5 degrees. So now my wheel reads right about 18 degrees. And I'm going to roll my crankshaft back the other way, hit the piston stop, and see where it lands. It's, oh, hang on. There, it's on the piston stop. It is right at 18 degrees. So I have zeroed my degree wheel now. It is truly on 0. One more time. It's sitting at 18 degrees. I rotate the engine back the other way. I hit my piston stop. There. And I'm sitting at 18 degrees. Now the degree wheel is truly zeroed, and now I can trust when I set the wheel to 0, it's going to read true. Now, I snugged this up enough. As long as the degree wheel doesn't move on the crank, you're good. So now I'm going to remove the piston stop tool, or at least the center portion of the piston stop. I'm going to move it out of the way. And now, if I were to set my degree wheel on 0, that is true top dead center, accounting for all that dwell. Now, I don't really need this measurement here. What I care about now is, with my degree wheel truly zeroed, now I can measure the timing on this flywheel. To do so, you want to look for the firing line. These flywheels have 3 laminate portions. Some people call them magnets. I don't know that they're all 3 magnetic, but basically you have this bottom one, this middle one, and this top one. The first edge here of the top magnet is your firing line. So if you line this line up with that coil leg, it will tell you what your timing is for this flywheel. And in this case, this flywheel is right at 20 degrees, which is consistent with these other 2 flywheels that I have measured in previous videos. So there you have it. We have our degree wheel set, my pointer, my degree wheel, my piston stop, set it to 0. And now if I wanted to uninstall and reinstall whatever flywheels I wanted to, I can check their timing. Again, I've already checked the timing on all 3 of these flywheels. This one's actually a Tillotson 212R cast aluminum flywheel from EC Carburetors. These other 2 are Amazon flywheels, and they all timed up perfectly at 20 degrees. Why is it important? If your flywheel times to only 20 degrees, you will need to advance that timing to even get to the stock timing of 24 degrees before top dead center. Even more so for performance applications, so you can do so by manually setting the timing using a degree wheel and locking the flywheel in place without a key at all, or you can buy a timing advance offset key. And then once you set that offset key and lock your flywheel down, when you set it up on this firing line, you'll see on the degree wheel, it will read the now advanced timing, whether it is 28 degrees if you added 10 degrees to an 18 degree flywheel, or in this case, if I added 10 degrees to a 20 degree flywheel, I would have 30 degrees of timing before top dead center. I hope that helps you out. Again, I'll put the links in the description for the actual degree wheel itself. Again, make your pointer, set up your degree wheel, zero your degree wheel using the piston stop tool. I hope you've enjoyed this video. Please like, share, leave a comment, constructive feedback. I'm doing these in one take. I don't have any fancy equipment. It takes me a couple of reshoots to get it all right. I might flub some words here and there. I don't have any fancy editing. These are going to be simple one-take videos, and I'm trying to help out the mini bike and small engine community any way I can. Thank you. Have a great day. Thanks for watching.